My name is Aida, and I work for Thoughtworks Barcelona. I've been working in QA testing related roles for almost 8 years. I started, like most of the people, by chance, doing a lot of manual testing. Then I moved to exciting automated testing, and I've been also managing QA teams. And right now, I'm developing with my team while playing the QA role. So this is it about me. Let's quickly start with the talk. So I wanted to start the talk with this slide. This is a Jenkins job, and it is executing an automated testing suite. And this testing suite has hundreds of end-to-end UI tests. And as you can see, all the builds are red. So please raise your hands if you've been in a situation like this. Okay. So the worst thing about this situation, and this already looks pretty bad, is that when you finally get a green build, you start thinking that something went wrong. Maybe someone changed the Jenkins job and the tests are not being executed, or maybe I'm not seeing the result correctly. Whatever, you don't trust your test. So in order to understand how did we end up in a situation like this, I want to go back in time and see what happened in the first place. So how did we end up in here? Imagine that you are working in a company that has a web application, and you've been given a new shiny project. So with your team, start discussing how are you going to implement it. And you start thinking about the testing strategy. And suddenly someone says, OK, I know unit and integration tests are really good, but they are not going to give us the confidence that we need. If we want to make sure that the user can exercise the application correctly, we need to implement end-to-end UI tests that go through all the layers, and we need to test the different behaviors in this way. So you think about it, and yeah, it kind of sounds reasonable to everyone, so this is the testing strategy that you are going to be following. And at the beginning, everything's fine. Your build is green, your tests are super fast, and you have confidence in what you're doing. So what do? You implement more and more of those end-to-end tests. And one day it happens. One test fails. So what do? You go to your test, you try to reproduce the error. However, you cannot reproduce it, so you don't really know what is going on. You have no clue. So at some point, you decide that you don't want to waste more time with this problem, and you hit the rerun button. And it goes green. Not a big deal. Well, you didn't know at this moment, but this is the moment when everything started going wrong. So what it happens is that with time, you start having more of those flaky tests. But as long as you press the rerun button and it goes green, not a big deal, until one day they don't. So you press the rerun button again, and again, and again, until it goes green. And without even realizing, you end up with hundreds of tests and a build that is never green. So now you regret that time you pressed the run button without spending the necessary time fixing your test. The problem is that now it is too late, because you already hate your tests. You hate them so badly. They are not giving you the right feedback loop. They are slow because you have too many of them, and they go through all the layers. And they are flaky. They are failing without a reason. These tests right now are really expensive. So you start thinking whether they are worth it. However, yes, you want to keep them, because you've been promised that with those tests, you are safe to go to production. And you don't want to lose this safety net. So here we have a quite tricky situation. So now we know how did we end up in the situation that I presented at the beginning of the talk. We also know that we shouldn't have pressed that rerun button. But there are probably more things that we could have done better. What about the testing strategy that we decided to follow? This is exactly what I'm going to be talking about in the next slide. So I want to present the testing pyramid super quickly. The testing pyramid has traditionally been the tool in order to plan the automation effort for your project. It was first introduced by Mike Cohn in 2009 in his book, Succeeding with Agile. And in his book, what he says is that in order to have an effective testing strategy, you should automate at 3 different layers. So at the bottom of the pyramid, we have unit testing. Unit tests are narrow, so when they fail, they give us a specific data about the failure, and they are super fast, so we can have many, many of them. Then I'm going to jump at the top of the pyramid where we have the UI tests. We want to have just a few UI tests, and this is because UI tests are usually brittle, expensive to write, and time-consuming. So, although there are many behaviors that we want to test, not all of them need to be tested at the UI level. And here is where the service layer comes in. Here we can test all those behaviors but disconnected from the UI, and this is going to make our test faster and less brittle. So the problem was that companies were completely ignoring the service layer, and they were filling that gap with lots and lots of UI tests. So that's why the testing pyramid came in order to give a guidance on how much testing you should be doing on each layer. And if you realize this is exactly the problem that we were having, our testing pyramid didn't look like this one. It actually looked more like this one. So here, what you have is lots of UI tests, and we've already seen that testing extensively through the UI is very expensive. So this is a very well-known testing anti-pattern. It is called the ice cream cone or the inverted pyramid. Here we have another anti-pattern, which is called the hourglass. Here, the situation is a little bit different. Here we have lots of unit tests and lots of UI tests. So what it could happen is that a lot of the logic that we are testing at the unit level, we are also testing it, or probably we are also testing it at the UI level. So we could have repeated tests, which we probably don't want to or don't need to. And then again, we are testing extensively through the UI, which it is expensive. The other thing that I wanted to show is the Swiss cheese syndrome. This is not known as a testing anti-pattern, but I think it's definitely something we need to be careful about. So here, the idea is that during the development of an application, there are several testing activities that take place. And it is unlikely that a single activity will cover the whole application. So here is where we have the similarity with the Swiss cheese. We have holes in our coverage. So if we don't have a complete view of all our testing activities, what it could happen is that we have a tunnel, like in here, that goes through all the layers, and therefore a potential bug that could arrive to production. So when we are planning our testing strategy, it is very important that first we take the testing pyramid into account in order to plan how much testing we should be doing on each layer while keeping a high coverage. And two, we should have a complete view of all our testing activities so that something like this is not happening. Now we are aware that the testing strategy that we were following wasn't the best one. We were focusing on doing too much end-to-end UI tests, and we were not putting attention to unit or service level testing. However, I feel that even though we followed the testing pyramid, that wouldn't be enough to get to the confidence level that we needed. I feel that we are missing something in here. So I'm going to keep talking a little bit more about the testing pyramid. So in 2012, Martin Fowler wrote an article about the testing pyramid, and he mentions the same core idea, that you should have many unit tests because they are fast and they are cheap, and you shouldn't have many UI tests because they are slow and they are expensive. So while he thinks this core idea is right, he mentions two very important ideas. This is the first one. A common problem is that teams conflate the concepts of end-to-end test, UI test, and customer-facing test. So I've seen in many teams, they think that all the end-to-end tests need to go through the UI, and that all the UI tests are end-to-end. And we will see that it doesn't have to be this way. The second idea that he mentions is that there is much more to say about building a well-balanced test portfolio. So when the testing pyramid was conceived, applications were monolithic, and it made a lot of sense to test them in this way. However, nowadays we have microservices, distributed systems, so this approach feels insufficient. So the thing is that I feel that most of the problems that we face when we are building or executing our testing strategy came from these two ideas, and I'm going to start with the first idea, the confusion between end-to-end and UI tests. And there is a talk that I really like, which is called Sub-Second Acceptance Test by Aslak Ezer. and he discusses exactly this problem. So in his talk, he starts with this same testing pyramid with Martin Fowler's blog. And he again mentions the same core idea, that you shouldn't have many UI tests because they are slow and they are expensive. So you may have not realized, but there is a hidden assumption in what I just said. And it is that UI tests are slow. It is not true that we want to have a few UI tests. What it is true is that we want to have a few of the painful and slow tests. So if UI tests weren't that slow, the testing pyramid would probably look very different. And that's why he proposes a new version of the traditional testing pyramid, which looks like this one. It is the love-hate relationship pyramid. So this pyramid, what it says is that we should have lots of the tests that we love. We should have just a few of the tests that we hate and make our lives miserable. And we should be somewhere in the middle with the tests that we don't either hate or love. And he calls them the meh tests. So in order to have lots of the tests that we love, we need to understand which are the characteristics that make us love a test. The first one is speed. We want to have fast feedback. And the second one is determinism. We don't want our tests to fail for no reason. So if you realize this love-hate relationship pyramid is telling us the same core idea as the traditional testing pyramid, but without making any assumption. And while it is true that most of the UI tests are slow, Aslak believes this is because they haven't been well thought. And he explains this idea very well in the following example. So imagine again that we have a web application. It would typically have these layers, database to store data, a repository to talk with the database, domain logic, an API, network, some client to talk to that API, front-end maybe with React, DOM, the browser, something to talk with the browser, maybe Selenium, and our test. So if we want to make our tests faster, we need to understand what from here is exactly making them slow. So tests are usually slow because they are I/O bound. And here what we have is the database, the network, and the browser. So what can we do to make them faster? Well, he makes the following suggestions. We could remove the database and use an in-memory database, and this is going to speed up things a lot. We could completely remove the API part and connect our front-end to the domain logic. Of course, we can only do this if we are using the same programming language. If we are not, we can just completely mock the backend. And then we could also remove the browser part and the Selenium part and use DOM actor to talk directly to the DOM. Or we could do all of them or a combination of them, depending on your needs. So what about brittleness? What is making our test brittle? Well, first we have all these layers, so the chance of something going wrong is just higher. We have the network. So network, it can be slow. We could have timeouts. And then we have the browser. Browsers are asynchronous. Different parts of the page load at different times. Plus, we have animations, pop-ups, and many, many other things that make testing through the UI just really hard. So as you can see, the same things that were making our tests slow and making them brittle. So same solutions would improve this characteristic. So if you realize what we are trying to do here by removing these parts, if moving those UI tests down the pyramid. So it is very important that we understand that UI tests do not need to be end-to-end. They don't need to be at the top of the pyramid. If we do that, if we move those tests down the pyramid, what happens with the confidence? Do we still feel confident with our tests? And here the problem is that we are trying to get different types of confidence, all from the same type of test, end-to-end UI test. We're trying to make sure that the logic works, that the UI works, that it works in different browsers, that it communicates to other microservices, all from the same type of test. And the cost of doing this is really, really high. So why don't we get these different types of confidence from different types of tests? OK, we already know that testing the UI doesn't have to be done in an end-to-end fashion. There are different testing activities that we can perform to test our UI. So here I make suggestions of a UI testing pyramid. So like the traditional testing pyramid suggests, we should have lots of unit tests. And nowadays, with modern JavaScript frameworks like React and Angular, it is possible to unit test the UI. So just take advantage of that and do lots of unit tests. In the next level, we have UI integration tests. So in the example that I showed before, I was explaining the different ways in which you can do UI integration tests. So I don't want to expand more on this one. In the next level, we have UI end-to-end tests. So in those tests, we probably want to include the browser and go through all the layers. So as I said, these tests are really expensive, just a few of them, because the logic is already tested in that part. So until now, I've been talking about testing functionality, but there are probably many other things that you want to check in your application. So the most typical ones are the look and feel of your application and if it is compatible with other browsers. So I'm going to start with visual testing. Visual testing is about making sure that your application looks good. There are different techniques in here, and each one of them is going to give you different types of confidence. I'm going to mention a few. We have a screenshot testing. So typically those tools use tools like Selenium to open the browser, and then you would take different screenshots of your application, and you would compare these screenshots to previously taken screenshots. And if they differ in an unexpected way, the tool will let you know. We also have layout testing. So layout testing is more about testing the properties of our web elements. And the main difference with screenshot testing would be that here it is more about testing the web elements in isolation, and screenshot testing is more about testing the whole composition of the page. What else? And the last one that I wanted to mention is DOM testing. So DOM testing is pretty much like a screenshot testing, but instead of comparing screenshots, you are comparing the DOM. So it is a little bit, the confidence that you get is less than with screenshot testing, and this is because what the browsers are rendering is not the DOM, is they're rendering 3, so there could be a bit of a difference in here. And then, the next thing that I wanted to mention about visual testing is that nowadays lots of the web applications are responsive, so you may want to test those visual tests with different screen sizes or viewports. And finally, we have browser compatibility. This is about making sure that our application behaves correctly in different browsers. And I didn't put this as another layer, I put it in another dimension. And this is because in order to check the compatibility with browsers, we may want to run some of those tests, a subset of them, or if they're super quick, all of them, in different browsers. And this is the way in which you can perform browser compatibility. There are probably many more things that we want to check in the UI, so if you feel that this is important for your application, go ahead and include them in your pyramid. So until now, I've been talking about a lot of theory. I wanted to show you a real example. I wanted to show how we applied the testing pyramid that I showed before to the project that I was working on before. So my project was a form builder. And here what you can see is the part that my team was in charge of testing, which was filling that form and submitting the results. And as you can see, this application was responsive. It also had to look well in mobile. So at the unit level, UI unit level, the things that we wanted to check were these little web elements in isolation. And we wanted to check two things, look and feel and the interactions. So these web elements, in our case, came from a design system. So the look and feel of them was already tested in there. We didn't need to care about that part. What we did was checking the interactions of them. In the next level, integration level, we decided that we would include the browser, but we would completely mock the backend. And this configuration, for our case, was enough to be able to test lots of behaviors very quickly and with enough confidence. So this is the configuration that worked for us. Then, in the next level, we have UI end-to-end. So we just implemented a few tests as an end-to-end fashion. And here we were removing the mock and interacting with the real services, which were two. Next thing was browser compatibility. So when doing browser compatibility, the first thing that you need to do is decide in which browsers you are going to be testing. And in order to do that, you may want to gather some data. So we gather data about the usage of our tool, and we also gather data about the usage in the market. So there is this really cool web page, a stat counter. Here you can see the most used browsers, devices, filtered by country. You can get lots of very useful data. So with all that data, we decided that we wanted to automate in 5 different browsers. Chrome, Firefox, Safari, Edge, and Internet Explorer 11. So we did automate in all of them, but in Internet Explorer 11, because Selenium was just not working with our application. The commands were just doing nothing, so we decided to do that part manually. And another thing that we did in order not to increase the build time is running all those tests in parallel. So here what we did was running all the UI integration tests in all these 4 browsers. And then what about mobile? Because I said this had to be working in mobile also. Well, we decided to test one of those UI integration tests in mobile devices, in an Android and in an iOS. And we chose the most complete test, of course. And we decided to only test one because, well, testing against real devices is really a thing, and it is very expensive, time-consuming. So we thought that our behavior was already very well tested in the other levels, so this was enough to get the confidence level that we needed with mobile devices. And the last thing that we needed to do was visual testing. So this part of the application was critical. It had to work in a lot of browsers, and it had to look pixel perfect. So we used this tool, ApplyTools. This is the image that you take, and this is baseline image. If they are not equal, the tool will let you know, and then you can decide if you want to approve that new image or you want to make the test fail or whatever. So here, for visual testing, we also run visual tests in different browsers and with different screen sizes, actually viewport. And this was because we wanted to make sure that it will look properly in small devices. So here we could have decided to use a real device, but that would be expensive. So we thought that resizing the browser to simulate the viewport of a mobile would be enough to get that confidence level. So here is about choices. So a lot of things about UI testing. Now I want to talk a little bit about microservices testing. How would the testing pyramid look like for them? So in 2004, Toby Clemson launched a really nice deck about testing strategies in microservices architecture. And basically what he's doing is adding new layers to the traditional testing pyramid in order to be able to manage the complexity that our microservices architecture brings. So typically, the layout will be like this one. You have your logic in the domain, you have the application with your services, and then the infrastructure. Maybe with a repository if you need to talk to a database, with a client if you need to talk to an external services, and then the controller to get a request from their side, maybe a user interface. So what he says is that in order to provide a good coverage, you should test each layer, between layers, and with everything which is outside of your application. So how does this look like for the testing pyramid? Again, at the bottom, we have unit testing. With unit testing, you will have a really good coverage for your components in isolation for each of your layers. However, you have no coverage for how those components interact between them. So in the next level, of course, we will have integration tests. So integration test is about testing the integration of our application with all the parts that live outside our application. And here we should be testing to make it effective, one integration point at a time. And typically we would have the integration with the database and the integration with that external service that we saw. And in the case of the external service, you may want to fake it in order to avoid having problems with that. And also something that is very important in integration testing is that you shouldn't be testing the external component. We don't want to test the database. That's not part of our work. We just want to test the basic success and failure paths. So the next layer is component testing, and the component testing ensures that the microservice works together as a whole to satisfy business requirements. So here we have a few options. We may decide to test against the real database and make real HTTP calls, or we may decide to use an in-memory database and avoid the network. This is going to make our test faster and less brittle, but we are also going to lose a little bit of confidence. So here, you need to decide what works better for your system. So with component tests, we have a pretty good coverage for our service. However, our service would probably talk to other services. So we have a few options to test this communication. We have contract testing, and we have end-to-end tests. And I'm going to first start with contract testing because it's just lighter tests. So contract testing is about making sure that the contract between two services is met. In contract testing, we shouldn't be testing functionality. This is already covered in component testing. We should be testing only the different contracts that two services have. So here I know about two options. The first one is consumer-driven contract testing. So in this case, it is the consumer, the one defining the contract, and the provider would be tested against that contract. And there is also another option, which is document-driven contract testing. So here what you're doing is that you are documenting the contract between those services, and then you would test both the consumer and the provider against that contract. Next, we have end-to-end tests. And here it's important to understand, as I said, end-to-end test doesn't need to go through the UI. You can also end-to-end test your API. So just go ahead and have a few of them. And finally, we have also included exploratory tests. So even though these tests are not a scripted test, I think it is a really good idea to put them in the pyramid so that we can show the effort that it takes. So until now we have UI tests, microservices tests. What about mobile? Of course, someone built a testing pyramid for mobile testing. So the problem with mobile testing is that it is really, really complex. It's not only about checking the UI. It is also about the network, the hardware, the different operating systems, the different versions of the operating systems. So it is quite complex. So there is a very nice article that I read which was showing this testing pyramid, and which states that the mobile testing pyramid should have 3 levels. So at the bottom we have browsers, of course simulating a mobile device. These are going to be the faster tests. Then in the next level we have simulators. And in the top of the pyramid we have real devices. These are going to be the most painful tests. So that's why real devices are at the top of the pyramid. I don't really want to expand more on the mobile testing because it is a really complex topic. I just wanted to give you a feeling of what is the thinking around mobile. And this is the latest pyramid that I wanted to show. This is the DevOps hourglass. And it was presented in the book A Practical Guide to Testing in DevOps, written by Katrina Kluke. So until now, we've been talking about testing prior to production in development environments. But what do we know about our application once it is deployed? Well, here the proposal is adding 3 more layers to the traditional testing pyramid, and they are logging, monitoring, and alerting. So this, as a whole, it is called as observability, and nowadays this is taking more and more importance. And this is because, well, nowadays systems are really, really complex, and testing everything it is just impossible. We need to accept that we shouldn't be trying to test every single thing. And we need to accept that there are bugs that are going to arrive to production. That's a fact. So what we can do is prepare ourselves, have tooling to be able to detect those bugs quickly, and ways to be able to fix them quickly. So this is the latest pyramid that I wanted to show. Of course, I'm missing lots of things, like what happens with testing against production, what happens with cross-functional test, security, performance, usability. There are many, many things. If they are important for you, just go ahead and see how can you build that testing pyramid for them. So, wrapping up a little bit. We've seen many, many different testing pyramids, from Mike-Cohn's testing pyramid to the DevOps hourglass. And we've also seen some of the patterns or things that you want to avoid doing. So the big question is, which is the testing pyramid that we should be using? And of course, the answer is that there is no answer. But there are some things that you can do in order to build your own testing pyramid. I think the first step is drawing the architecture of your application. It is very important that you know it very well. The second step is that taking that architecture into account, try to build your testing pyramid, and taking all these examples into account, they can inspire you. It is important that you follow the core idea of the traditional testing pyramid, which is that you should have lots of the tests that you love and just a few of the tests that are very painful. As much as you can, try to move a test down the pyramid, okay, to make them faster. Have a complete view of all your testing activities so that you make sure you are not missing anything, and get different types of confidence from different types of tests. So going back to the topic of the talk, are UI tests dead? Well, no, I don't think UI tests are dead. I think it's really important to test through the UI. What I think it should be dead is having a trusting strategy that relies on doing end-to-end UI tests that go through all the stack. So that's all. Thank you very much.